Alright, Math 12th. Today we're going to take a look at section 3.4, and we're going to talk about polynomial functions and equations. So let's take a look at a couple of polynomial functions that you'd be familiar with. Some that are actually quite simple. Y equals x. We'll look at y equals x squared, y equals x cubed, and y equals x to the power of 4. Now each of these are fairly straightforward. Y equals x we know is just a straight line. It's got a slope of 1 and a y-intercept of 0. It's a linear function that passes through the origin, like so. Y equals x squared, by the time you've gotten to grade 12, you've seen a lot of that. It's a quadratic function with a vertex at 0, and the y value is equal to whatever the x value is squared. So over 1 up, 1 squared. Over 2 up, 2 squared. So we get these points, and we get our famous parabola. Y equals x cubed, a cubic function. The y coordinate is equal to whatever the x coordinate is cubed. So if x is 0, y is 0. If x is 1, y is 1 cubed. And if x is 2, y is 2 cubed, which is up there at 8. So you get a graph that looks like this over on the right side. And on the negative side, if x is negative 1, y is now negative 1. And if x is negative 2, y is going to be negative 8. So we've got a graph that comes down like so. And finally, for y equals x to the power of 4, same thing as we saw before. When x is 0, y is 0. When x is 1, y is 1 to the power of 4. But when x is 2, y is going to be quite high here, way up high. The thing that happens is inside here, when x is a half, y is going to be 1/2 to the power of 4, which is 1 over 4, 8, 16, very low. So as the parabola sort of came up towards the 1, this one ends up staying quite flat before sharply going up. Stays quite flat and sharply goes up. Okay, flatter around here than the parabola is. So what happens then when we take y equals, instead of y equals x, we take y equals x minus 2? Well, we saw that in chapter 1 when we looked at transformations of functions. If I've got an h value inside my function, that moves my graph to the right too, like this, boom, etc. And we get a graph that's been moved to the right. If I've got a quadratic here, that's been moved to the right. So all of these points just shift over. And you saw that before. Over here I've got a cubic that's been shifted to the right. And finally my quartic function shifted to the right. Remember, it stays quite flat down low and then goes up quite sharply. So let's analyze what happens as the function gets close to its zeros. So let's take a look at some language here. If we take a look at the root of this function, it has a multiplicity, we say, of 1. There was one root. This one over here has a multiplicity of 2. There are 2 identical roots, x minus 2 squared. This function has a multiplicity, or this root, I should say, has a multiplicity of 3. There are 3 identical functions, or 3 identical roots. And this function has a root with a multiplicity of 4. So what does that mean? Well, if the function has a root with a multiplicity of 1, that function crosses the x-axis at 2. The sign of the function goes from negative to positive. Okay, whatever the y value is here is negative, and then when we cross through, or when we go past that root, the sign of the function changes when we cross the x-axis. Over here, when the multiplicity is 2, the sign doesn't change. It's positive, 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 gets to 2, and remains positive again. It's like it bounces. The sign stays the same. When my multiplicity is 3, another odd number, my sign changes again from negative to positive. And when my multiplicity is 4, or another even number, like 2, the sign stays the same again, positive and positive. So when a polynomial has a repeated factor with an exponent n, we say it has a 0 with a multiplicity of n. So for example, if I had y is equal to x minus 2 squared times x plus 1 cubed, we'd say that we've got zeros of x is equal to 2 with multiplicity of 2 and a 0 at x equals negative 1 with multiplicity of 3. Multiplicity of 2, the sign stays the same, so it's going to bounce, let's say, and a multiplicity of 3, the sign is going to change, and we saw that up above where the graph is going to come in, cross at negative 1, and bounce like that. And this one is going to come in at 2 and bounce. Okay, the sign of the function is going to stay the same. So let's look at how we could sketch the graph of some different functions. Just sketching using the information here that we have about the zeros and their multiplicity. We know that the roots, or the zeros here, are going to be x equals negative 2 and x equals 2, and each of those has a multiplicity of 1. That means the graph is going to cross through those points. This, of course, is a positive quadratic function, so we know the end behavior is going to start in quadrant 2 and end somewhere in quadrant 1. It's going to cross through negative 2 and positive 2, so it's probably going to do something like that, crossing through those points, starting high and finishing high to the right. The second one is a cubic function. It's got a single x and a double over here. So multiplicity of 1, multiplicity of 2, for a total degree of 3. It's a cubic function. The 0 here is negative 2, and the 0 here is 2, but with multiplicity of 2. So it's going to be like a double 0. It's going to bounce there. So I'm going to cross here, and I'm going to cross here, and I'm just going to show that with a little bullseye there to show that that's got multiplicity of 2. Now, a positive cubic, just briefly, looks something like that. The end behavior starts in quadrant 3 and ends in quadrant 1. So I know I have to cross through that point. So I'm going up through it, and then I have to change direction, come back down, and then go back up again. The sign of the function is not allowed to change when the multiplicity is 2. Next, we've got a quartic function. Multiplicity of 2, multiplicity of 1, multiplicity of 1. So our total degree here of this function is 4. That means I've got a 0 at negative 3. I've got a 0 at 1. And I've got a 0 at 4. Change the scale here on my graph to make this negative 2, negative 4, 2, and 4. And we'll continue to work up as 1, 2, and 3. So I've got a 0 at negative 3 with a multiplicity of 2. I've got a 0 at 1, and I've got a 0 at 4. This is a positive quartic function. That means it's going to look something like this. End behavior starting in quadrant 2, ending in quadrant 1. It's going to bounce here and cross through these. So if I know if it's ending up here, It's going to have to change direction there, or not change direction, but change sign, and then bounce here and go back up. Okay, so a double, 0, a single, and a single. Changing signs, but not changing signs when the multiplicity is 2. And finally, we've got this quintic, or this fifth degree function. We have a 0 at -1. That's got a multiplicity of 3. And we've got a 0 at 2. That's got a multiplicity of 2. Multiplicity of 3, our sign changes. Multiplicity of 2, it doesn't. So here it's going to cross, but here it's going to bounce. It's an odd function, which means it's going to start down low and go up high. It's going to cross through here, come back up, and bounce. Now watch what happens though. So it's going to come up, really flatten out, go up, come back down, and then go up again. So that's our quintic function. So there you have a little bit on sketching the graph of a polynomial function. Okay, with two zeros, with 3 zeros, a double over here, with a double and 2 singles, and then with a triple and a double. Okay, multiplicity of 3, multiplicity of 2. Hope that helps you a little bit. Take your time, review it again, and we'll see you in class.